Section 4.3 Complements and Conditional Probability. In this section, we are going to learn how to find the probability of at least one. When finding the probability of some event occurring at least once, we should understand the following. At least one has the same meaning as one or more. The complement of getting at least one particular event is that you get no occurrence of that event. For example, the number of occurrences of an event can be 0, 1, 2, 3. 0 means the event did not occur. 1 means the event occurred once. 2 means the event occurred twice. 3 means the event occurred 3 times. At least 1 means 1, 2, and 3. While 0, 1, 2, and 3 make up a whole, that means the event when the occurrence is none is a complement of at least one. If I let A be the event of getting at least one of some event, then A bar, the complement of A, is the event of getting none of the event being considered. To find the probability of at least one, I have to use the complement rule. Probability of at least one occurrence of event A equals 1 minus probability of no occurrences of event A. Or, to make it simple, I can say probability of at least one equals 1 minus probability of none. Example 1. A study by SquareTrade found that 6% of damaged iPads were damaged by bags or backpacks. If 20 damaged iPads are randomly selected, find the probability of getting at least one that was damaged in a bag or backpack. I am looking for the probability of at least one. My event is getting at least one that was damaged in a bag or backpack. So that is my event A. Next, I am going to look for the complement of A. Complement of at least one is none. Complement of A is the event that not getting at least one iPad damaged by the bags or backpack. That means all of the 20 iPads damaged in a different way other than bags or backpack. Probability for one iPad getting damaged by bags is 6%. That means the probability for one iPad getting damaged other than the bag or backpack is 96%, and we have 20 of them. So P of A bar equals 96% to the 20. And that is 0.290. So to find the probability of at least one, P of A is 1 minus P of A bar, 1 minus 0.290, which is 0.710. Example 2. Find the probability that when a couple has 5 children, at least one of them is a girl, assuming that boys and girls are equally likely. So, event 8 is the event of having at least one of them is a girl. The complement of A is the event that not at least one of the children is a girl. So when you have 5 children and none of them is a girl, that means all of them are boy. Next, we are going to find the probability of 5 boys. we need to figure out the total number of combinations of 5 children. Each child will either be a boy or a girl. So for each child, we have 2 possible outcomes, either boy or girl. And we have 5 of them, so we raise it to the 5th power. That is 32 different combinations. And in these 32 different combinations, how many combinations of those are 5 boys? There's only one, where they are boy. So probability of A bar is 1 over 32. To find the probability of A, I take 1 minus probability of A bar, which is 1 minus 1 over 32, which gives me 31 over 32. Conditional probability. A conditional probability of an event is a probability obtained with the additional information that some other event has already occurred. The notation for conditional probability. Probability of B given A denotes that the conditional probability of event B occurring given that event A has already occurred. What does that mean? It means that you want to find the probability of B given that you know A already happened. So this event is the event that already happened, and you want to find the probability of this event. The formula for probability of B given A equals probability of A and B divided by the probability of A. Example 2. If one of the 555 test subjects is randomly selected, find the probability that the subject has a positive test result, given that the subject actually uses drugs. That is, find the probability of positive test result, given subject uses drugs. I'm given a table. The first column lists out the number of people who have positive test results. The second column is the column lists out the number of people who have negative test results. First row is the row lists out the number of people who actually use drug. Second row is the row of people who did not use drug. The first thing I'm going to do is always find the total of the columns, total of the rows, and the grand total. I want to find the probability of positive test result given that the person actually uses drugs. This is the condition that they gave me. They told me that that person is using drugs. That means I'm not going to look for a person in 555 people. I know that the person is actually using drugs. So I'm looking at the row of the people who actually use drugs. There are 50 of them. So the probability is out of 50 because the condition is the person actually using drugs. Now, out of these 50 people, how many of them have positive test result? 45. And the answer is 0.9 or 90%. Question B, I am given the same table. I want to find the probability that the subject uses drugs given that the positive test result. I want to find the probability of subject uses drugs given that that person has positive test result. So I know for the fact that the person has positive test result. I'm not going to look for the person in 555 people here. I know the person has positive test result. I am going to narrow down to look into a group of positive test result only. The group of positive test result has 70 people. My probability will be out of 70. Out of these 70 people, how many of them actually uses drugs? 45. And I get 0.643. So as we can see, if we reverse the two events, the probability is different. So the order does matter. Probability of B given A is not the same as probability of A given B.